Great, thank you very much. First of all, thank you very much for joining us here today. I know you guys had a lot of options at this time, so it's great to see this many folks decide to spend an hour with myself and my RightScale colleagues to talk to you about the best of both worlds implementing IT with AWS. A couple of housekeeping things before I get started, if you don't mind. The first and foremost is that I often get asked at these discussions, hey, will I get access to the slides after the fact? And yes, you will. We have the slides posted. We will have the slides posted on the RightScale site. They're probably going to be on the AWS site as well. I don't know how to navigate to that. I wasn't given that information yet. If you go to rightscale.com, there's a resources link at the very top, and there's a resources slide decks or something like that. It's pretty obvious once you get there. So we'll have those posted probably pretty quickly in the next day or two if folks are interested. This is also being videotaped, and that's a question that I will ask AWS. I'm assuming that these will all be available for download and view on the AWS site after the fact. So again, hopefully that will be easy to find for you all. The other thing I wanted to ask is that our marketing folks had said that we did not have our little scanner things. We weren't given those in time. So if you don't mind as you leave, if it's not too big of an inconvenience to get scanned so we know how many folks were here and who was all here, that would be wonderful. A couple other things is that if you're wondering, if the stage is tipped at all, no, that's me. I threw out my back the day I was supposed to come here. Every time I come to Vegas, there's usually another conference co-resident. I was hoping like the American Chiropractic Association would be here, but they weren't. So it's not the stage, it's not your set, it's me. And then the last thing was, as far as the PowerPoints are concerned, well, first and foremost, the PowerPoint skills are weak with this one. So you're not going to see any cool animations and slides and all that kind of stuff. Like I used to tell my boss, I do stuff, I don't do presentations about doing stuff. But hopefully we'll get the content out here to you as well. There are a couple slides in here that I'm hoping I can definitely update them on the RightScale site when it comes time to download them. I put in some placeholders when we talked about connecting the clouds. AWS understandably had some pretty aggressive timelines when you needed to pre-submit your slides, and life got in the way and I wasn't able to draw the pretty pictures that I wanted. Again, my PowerPoint skills are limited, so it took me a lot longer. So I have some placeholder slides in here. So I will talk to the points that I have on my cheat sheet slides down here, which will be the ones that you guys would be available to download if you wanted. The other thing is, usually this isn't too big, which is great. I've done some of these where there's, 5 times as many people, and it makes it hard to be interactive. But I can see you all, which is good. And it's a little bit blinding, but I can see you. So if you folks have questions as we go through, feel free to interrupt. I left a big chunk of time at the end for Q&A as well. But if there's anything that's pertinent, to something I'm talking about right that moment, please feel free to catch my attention and we can discuss it, okay? All right, so with that said, hi, I'm Brian Adler. I'm the architect in the services organization at RightScale. In that role, I've talked to hundreds, probably approaching 1,000 by now, of customers. We've been doing this for about 5 years. RightScale's been doing it for about 7. And the customer base has run the gamut from the small to the tall, or as my boss used to like to say, from the 2 guys in the garage with a credit card and a dream, all the way up to the largest enterprises. And with that wide, diverse customer base and prospect base that we've talked to, we've seen a lot of applications and a lot of different use cases of the cloud. So we have a very broad spectrum of experience to draw from and to discuss with you guys. So what we're discussing here today is, in the last 2 years, 18 months, 2 years or so, we've seen a huge push, obviously, towards the hybrid IT environment, right? 4 years ago, it didn't really even exist. 3 years ago, it was starting to become an intriguing possibility. And in the last 18 months, 2 years, folks are now going, in the last 12 months or so, folks have been going production on some of these hybrid IT environments. So it's been the biggest sort of uptick, if you will, in the customer engagements that we get involved with, is folks discussing hybrid IT, particularly in the enterprises. And we'll talk a little bit about some of the enterprise aspects to this as we get a little bit deeper, okay? So we already went through that. The agenda, talk a little bit about what is hybrid IT. It means different things to different people, and there's a lot of terminology out there. Some of the terminology you might hear at this conference might be a little different than what you typically hear when it comes to, in the common literature and stuff. So I'll do a little bit of level setting. I usually like to do that with terminology just so that for the next hour, we're using words and phrases to mean the same thing. So we'll talk a little bit about that. We'll then talk about some hybrid IT trends. As I mentioned, with this very large customer base and this huge amount of influx of hybrid IT requests that we've been seeing, we're starting to see some really interesting trends through the whole hybrid IT phases of particularly the enterprises. And we'll talk a little bit about what we've seen, some of the surveys that we've run and the data we've collected, which we found quite interesting. Then talk about use cases. There's three in particular that I want to talk to. They are probably ones that you are more or less familiar with. There's some that Andy Jassy touched on this morning. There's some that in those promo videos sort of before he came out, some folks were talking about some of those there as well. We'll talk about a couple of those customers we've seen do these particular use cases and customers that maybe said, hey, I absolutely want this. And then once we talked to them about the caveats, if you will, they said, you know what? Maybe I don't want that. Maybe I'm not ready for that, or maybe my environment is not suited for that. And we'll talk about those considerations and those pros and cons. Then we'll talk about connecting your hybrid IT environment. And that's those placeholder slides that I said. So I'll do some hand waving and talk about the points as opposed to the pretty pictures you'll see up there. But basically, there's three main ways. There's a slew of ways, but basically we can categorize them into three main ways that we see folks connecting their hybrid IT environments. So we'll talk about those. And again, Andy Jassy actually touched on one of those earlier today in the keynote as well. Then we'll talk about management, and that's sort of where this is. I'm on the services side of RightScale. I'm not on the marketing side, so I'm going to try to keep this from being a marketing plug, but obviously some of the stuff I'm going to talk about is how we do things, because that's how we've seen it be most effective, right? We kind of eat our own dog food or drink our own champagne or whatever the right word is, so we've learned how to advance our own technology to meet our own needs and therefore meet the needs of our customers as we listen to them as well. So a lot of the management tools that we see, we do feel are best practices and give you that single pane of glass view, you know, one screen to rule them all sort of concept. So we'll talk a little bit about the management there as well. And then, as I mentioned, we'll have a little bit of Q&A at the end. Before I jump in, I am curious, like I said, this isn't going to be a RightScale thing, but I am curious, how many of you folks here are either RightScale customers or have used the free edition or familiar with RightScale, sort of a little bit of hands-on? Anybody? Okay, I see just a few hands going up. Okay, how many of you folks are familiar with RightScale and what we do? Okay, more hands going up. Okay, so when we get to the time where I talk about how we do some of these things like disaster recovery and things, I'll go into a little bit of RightScale detail. Again, it won't be a marketing thing, but more of just this is the tech, how the tech works, so that we're all on the same page in that regard. And then, as I said, at the end, we'll have some time for Q&A, but feel free to interrupt as we go through. Okay, what is hybrid IT? Well, basically a combination of this, right? And probably not a big surprise here, but sort of your on-premises IT, the stuff that you have, the stuff that you own, or the stuff that's co-located for you, be that on physical nodes, or be that virtualized, or be that running on some enablement technology like CloudStack or OpenStack or Eucalyptus or whatever it may be, right? Your stuff, right? Again, whether you own it or somebody owns it for you or manages it for you. And then the cloud resources, the public cloud resources, the AWS side, right? So it's some sort of combination of those two to meet your capacity needs or your capability needs. And we'll talk a little bit about those in just a second. So I mentioned I want to talk a little bit about definitions and terminology. On-premises IT, I'll just kind of read this here real quick. Compute, storage, and network resources for a single tenant that are accessed programmatically via an API endpoint. In the common literature, you might see this referred to as private cloud. So if you hear me say on-premises IT, you can kind of synonymously in your head say private cloud if that's what you're familiar with reading. But basically the point here is that it's, again, gear that is virtualized, that you can access via an API endpoint to spin up compute and storage and network resources. It's single tenant in that it is for you or for your business unit or for your company or whatever that case may be, right? It's your stuff, you own it, or at least you are the only ones that have access to it. Typically, you'll see that managed under, as I mentioned, you know, the OpenStack, CloudStack, and Eucalyptus umbrella, if you will. Cloud architecture or the cloud, similar set of resources, right? Again, these here now are multi-tenant and managed by a cloud provider, i.e. AWS, right? Now, there's always exceptions to the rule, right? I say here a similar set of multi-tenant resources. For those of you who are familiar with Amazon's dedicated instances, right? You can actually have a physical node that is running just your VMs, right? But you're still accessing a common API endpoint. It's in a common infrastructure. Your VMs might be segregated, but it's still a shared environment by a lot of folks, right? Hybrid IT, an environment that spans that cloud provider, the AWS cloud provider, and your on-premises IT stuff, right? In the common literature, you might see that as a hybrid cloud. So again, if you hear hybrid IT, it kind of means hybrid cloud sort of synonymously through this discussion. And then multi-cloud, basically a superset, if you will, of hybrid cloud. Basically just an environment that has more than one, right? It can have one of each. It can have two AWS regions, right? We at least think of AWS regions as separate clouds because they don't share resources, right? You can't have security groups go across. You can't have EBS snapshots go across. They're basically segregated, okay? So we essentially think of those different regions as different clouds. But that could also span not just AWS regions and your on-premises IT configuration, but also another cloud provider if you use it or whatever, right? So that's sort of multi-cloud, more than one, regardless of what those two or more are where they're running, where those resource pools are running. So capacity and capability. Probably should have put this slide one up so that it was more in line with what we talked about. But the concept here is that you have resource pool A and you have resource pool B. Maybe resource pool A is AWS, and resource pool B is your on-premises gear, right? Your on-premises IT resources. And in order to meet your capacity needs, your C, you go ahead and utilize both of those, right? And that's sort of what I think Andy was talking to a little bit about the cloud bursting. I don't know if he used that phrase, but that's sort of the common concept there, right? Is that you try to utilize your on-premises resources. You've already paid for those, and whether you're using them or not, you're going to be paying for those resources, the power, the cooling, the FTEs to manage them, all that kind of stuff. So you try to utilize as much of those on-premises resources as you can. If you get to a point where you exhaust those resources and you need to spill out and you need additional resources, you can go ahead and consume the resources in the public cloud in AWS. And that will fulfill that capacity need that you have, right? So you go ahead and you've met the needs that you have for this capacity when you didn't have it internally. That's one of the use cases that we'll talk to. I mentioned in the agenda we'll talk about use cases, so we'll talk about cloud bursting and I'll go into a lot more detail on that. Talk about some of the customer use cases where we've seen that work, and customers came to us and said, you know what, actually I don't want to do that yet. All right, so talk about that. The next one is capability. And by capability, what we mean here is you have workload X that maybe is destined for resource A. So maybe that's, again, your AWS resources is resource pool A. And you have another workload, workload Y, that you want to go ahead and run in resource pool B. And that is the example, I think Andy had mentioned that some companies have this concept that certain aspects of their workloads must run in the on-premises data centers. And he says that I'm going to misquote him here, but basically the gist of what I think I heard him saying was that he feels that the number of companies that are going to have that mindset is going to become very, very small in the future. And that may be true, but we'll talk about in the use cases again here. There are some exceptions to that rule, right? There are governmental restrictions that might mandate that you need to keep certain data or certain information within the borders of the country in which it originated. And that's not an enterprise company's decision, that's a governmental thing, right? So, there's sort of the speed of enterprise and there's the speed of government, right? So that's going to be there for a while, right? It's probably going to be a long time before, if ever, those particular regulations are relaxed. So we'll talk a little bit about that and the caveats around it when we get to the use cases here in just a few minutes. Okay. Some of the trends that we've been seeing. As I said, we've got thousands of customers. We've sent out earlier this year, I think actually it says on here, was it Q1? Yeah, we conducted this survey in the first quarter of this year, sent it out to a bunch of RightScale customers, prospects, partners, kind of anybody we had contact info. We had 625 respondents, and we asked them a bunch of questions, but the gist of them that I felt were relevant for this talk, I've tried to capture here. And these are from an enterprise perspective. How many enterprises, the question was, hey, if you're enterprises, how many of you want a multi-cloud or hybrid IT environment? How many of you that's your goal, that's your where you want to end up? More than three quarters, right? 77% of the respondents said, yeah, that is where we want to be, right? Maybe not be where we are right now, but that is where we want to be, okay? And you see the breakdown there as well. There were some folks who were saying, hey, 5% are saying, I just want to be in the private cloud or the private IT on-premise environment. Others are saying, hey, AWS is fine by me. That was 11%. And folks that actually said, I have no plans to go into the cloud, which was surprising. It was actually 7% of enterprises are still in denial, if you will, or whatever. So, but of that 77%, you see the green graph there breaks it down. The majority of those, 47%, were saying, hey, we want hybrid IT. We want to have our on-premises stuff, and we want to have our cloud resources stuff running in AWS or wherever else that may be, right? You also see the breakdown for multi-public and multi-private, 15% each. But the interesting takeaway there is that fully 47% of the respondents said, yeah, we want to be hybrid. That is our plan to get there. We then asked them about their current cloud usage. So this is for organizations that have a hybrid IT strategy. They're already thinking about this, whether or not they're doing it or not. How many are currently running apps in the cloud, right? 61% said, yes, we're running apps in the cloud. 39% said, no, they weren't. And then currently running apps in the on-premises environment, right? 38% were already running applications in their on-premises environments, and they're virtualized. Most of these folks we talked to were running either OpenStack or CloudStack, and were running production applications in some cases. A lot of it was dev and test, but some of it was production as well. And the interesting takeaway is almost 30%, 29% were running apps in hybrid environments. They already had gotten to this point. So 77% want to get there, 29% are already there. All right? And this was in Q1 of this year, so obviously things have probably advanced in the last 8 months or however long it's been since this survey has been conducted. This is from, at the bottom there, it says the RightScale State of the Cloud. That's not a white paper is a wrong word, but a brief or whatever that you can download from a website if you want to get the detail behind the data behind all of this and the details around it. So that's available for you guys to download if you want. Okay, use cases. I'll spend a little bit of time here delving into this. I just got a few pictures on it, so it'll be a lot of time we'll spend kind of digging into this verbally. The first one, cloudbursting. And just kind of want to go through this definition here so that we're all on the same page about what it means, and then we'll talk a little bit about the caveats around it. An application deployment model in which your app runs in your on-premises environment and then bursts out into the public cloud and your cloud provider, i.e. AWS, when the demand for computing capacity or storage capacity, typically computing capacity, spikes up, right? And you see the second bullet there. The advantage is that you're only paying for, obviously it's utility computing, you're only paying for those public cloud resources when you need them, right? And in theory, like we said, you want to configure your environment such that you're consuming all of your own stuff first before you burst out. You're already paying for this. Make sure you utilize it to the best of your ability. Only burst out and have to pay for that public resources when you actually need them, when the demand spikes. So this is where the lack of PowerPoint skills come in, but the goal here was to show you that on the left side, in your on-premises environment, you've got your app running, right? Everything's all good. You've got your load balancers, you've got your multiple application servers, you got your master database, your slave database, you're taking snapshots to your object storage, all is good. Everything's good. What happens when I run out of capacity? All of a sudden I have some viral event, or I get slash-dotted, or we used to call it the Oprah effect. Some of our customers would get mentioned on an Oprah show, and the next day their thing would just come hammering down, right? You know, what happens what do you do when that happens, right? Well, the concept here is that, hey, you know, typically the application server tier is the one that we're going to want to scale, generally, right? I mean, there's other ways to handle the databases and the load balancers as well. Typically, it's the app tier that you want to scale out. So what you do is you go ahead and you burst out that application tier into the public cloud and consume those resources. And when that slash-dot event dies down or the Oprah show's over or whatever, everything comes back in, right? So in theory, it's beautiful, right? It makes a lot of sense. It sounds great. The only problem with this is it's drawn right here. And we'll talk about environments where it makes a lot of sense. There's a couple caveats that I always talk to customers about when they see this. And it's probably intuitively obvious, at least when you give it a little bit of thought, but security, latency, and cost, right? So it's sort of the three legs of that stool that you need to worry about, right? That's the public internet that you're traversing right there, right? And as I say in my other demonstrations, you know, there be dragons, right? You have no idea what's going on out there. You're going on the public internet, and there's people out there that are looking for your packets and trying to figure out what's in your packets, right? So you got to deal with security. There's a bunch of ways to do that, but security is one of those necessary, I won't say evils, but one of those necessary things that you need to implement that takes time and resources, right? So it's something that you need to do on top of what you're already trying to accomplish. So it adds a level of complexity. Latency, right? Again, same thing. You're traversing the public internet at this point. You know, TCP does a great job of getting your packets there, right? But it's the best effort protocol. It makes no guarantee of when they're going to get there or what order they're going to get there in. So you need to be tolerant of that. And if you're in a user-facing application where your users are going to experience this latency and are going to be upset with this latency if it exists, maybe this is not a good model for you, right? Because you cannot control that public internet traversal, the hops that are involved, and the inherent latency that might be as a result, right? And also your bandwidth might be constrained. The ability for you to get the data out and get the data in. Again, the characteristics of the network between A and B are going to really factor into that. And then the last one is cost. With AWS and most of the major cloud providers, and it depends on how your ISP is set up for your on-premises, a lot of times the data ingress is free, right? Data ingress coming into AWS is free. Anytime you leave AWS, you pay for that bandwidth on a sliding scale, right? The more you spend, the less it is per gigabyte or whatever. But for an app that's super chatty or something where you're going to have a lot of application servers and you have load balancers talking to the apps and then the apps talking to the database and all these round trips, maybe it adds up, right? So that cost is something that you need to factor in as well, right? Again, in your on-premises environment, you've already got that sunk cost, right? So at this point, it's sort of a known fixed cost. When you start bursting out, you have to worry about not just the instance hour cost for all those servers, but also the cost of the bandwidth going to and from, right? So again, those are the three things that I generally talk to folks about is cost, security, and latency. So a lot of customers, and it's changed in the last 6 months or so, but say 2 years ago, when sort of this whole concept came out and people were like, hey, that's really cool, that is what I want, we would sit down with them and we'd talk to them about these things, and they'd go, you know what, maybe that's not what I want. I'm not quite ready for that, or my app's not well suited to that, or I need to reconfigure my network or reconfigure where my gear is, and we'll talk about that in a second. So it's probably the #1 most requested use case that RightScale sees for hybrid IT, but not the most implemented, right? So folks come to us saying, this is what I want, and the vast majority go, no, it's not, right? What I want to talk about next is the one that we do see folks implementing the most common one. And that's disaster recovery. And as I mentioned, I think in one of those promo videos before the keynote today, there were some folks, I missed the company name, that were talking about how they leverage AWS for disaster recovery. And this is where we see a lot of our customers, right? Probably this is the second most requested hybrid IT environment that RightScale sees as far as its customers are concerned, and the most common one to be implemented for sure. We have a lot of customers that are doing this. The most common environment is they have their production set up and they're on premises. So they're running, I'll give one example of a customer. We have a customer that's running an OpenStack on-premises IT environment. They have everything running within that environment, all is well. Everything so far has been great. They haven't had any outages, but they want to make sure that they're up and running in the case of a disaster, right? They are in a single data center. They are subject to power outages and network issues and acts of nature and all that kind of stuff, so they want to have a disaster recovery environment. So they've set up the DR environment in AWS. And this particular customer is actually an APAC customer. They've set up their DR environment in AWS US Oregon, right? And they said, okay, if there is some sort of natural disaster, hopefully it ain't going to span that far, right? So that's a good idea. They're going to kind of put their DR environment far, far away. And the point of a DR environment is, right, it's sort of an insurance policy, and if I have to, I'm going to go over there, but when I can, I'll come back. So in this case, if they're going to run their DR environment in US Oregon, they're going to have latency issues for sure, right? But they're still going to be up and running. And when whatever happened is sorted out, they can go ahead and move stuff back. The most common configuration, the one that we recommend to folks, is what we call the warm DR scenario, or in AWS parlance, I believe they call it the pilot light. So if you guys are familiar with the pilot light concept, it's kind of the same thing. The plan there is to get your replicating slave in that public cloud or in the DR environment. Some folks do this the other way, but typically it's on-premises production, DR is out in the public cloud, and all the other servers are in a non-operational state. And this is where I'll talk a little bit about RightScale real quick, just to give you a concept here. But what this picture is showing, again, is you've got on the left side, you've got your on-premises gear. Everything's running, your apps, all is well. All your traffic is being pointed to your load balancers, and everything is fine. You've got in the cloud, you've got your DR environment. And what didn't show up here so well, and I apologize, is that the slave database is supposed to be in a different color, showing that's the one that's running, right? All these other servers are not running. So that's where we call it, they're basically cold. The slave is running, and therefore there's your warm scenario. You've got one server that's running in the public cloud that you're paying for, and the storage associated with it. So this is a minimal cost sort of DR environment. And where I said about as far as where RightScale comes in, we have this concept of what we call a server template, which you can kind of think of as a blueprint for a server. Basically, it's an image, right, whatever your Linux or Windows flavor of OS is, and then a boot list of stuff that's supposed to be installed and configuration options and all that stuff to create that server automatically. You can click a launch button. It will come up and be whoever it's supposed to be, right, with no manual intervention. The server template the server template rides on top of images that are supported in all of the public clouds that we support, plus all the private clouds that we support. So we also have some for KVM and OpenStack, and we have some for Zen and CloudStack, et cetera, et cetera. So the concept here is that they have these server templates, these server objects that are staged over in their DR environment, and if something bad happens, something real bad happens in their on-premises and they have to fail over, what they do is they promote that slave database to master. They then go ahead and click the launch all button. I don't want to oversimplify it, but it almost is that easy in RightScale. Launch all button, which launches their application servers and their load balancers. And using our framework, excuse me, we have a tagging system where basically load balancers come up and advertise themselves as, hey, I'm a load balancer for this environment. And app servers come up and say, hey, I'm an application server for this environment. And the two meet, and they exchange the information they need, and the application servers register with the load balancers, and the application servers find the database servers and initiate their connections, et cetera, et cetera. And once all that's good, then what they do is they go ahead and they flip their DNS over, right? They go ahead and they point their DNS, which was pointing at their on-premises environment, and they point it off to their public cloud environment, and they're back up and running. Now, this is all about RPO and RTO. For folks that aren't familiar with those phrases, I'm sure you're familiar with the concepts, but the RPO is a recovery point objective, and that's basically, in a nutshell, how much data can I afford to lose, right? Obviously the goal is 0, but how much data can I afford to lose? Can I afford to lose an hour of data? Can I afford to lose a day of data? Can I afford to lose a second of data? And that's something that each and every one of you needs to answer on your own, based on your own company's policies and the SLAs you have to your customers and things like that. Then the RTO is a recovery time objective, and that's how long does it take me to get back up and running, right? Can I be down for an hour? Can I be down for a day? How long is an outage? Obviously you want 0, but what is an acceptable period of that outage, right? So for this particular customer that I was talking about that has this DR environment set up in AWS US West, they haven't had to exercise this for real yet. They've done a bunch of dry runs and all that kind of stuff. Now, granted, they did this at Tuesday at 10 a.m. after they'd all had their coffee and everybody was ready, right? Usually it happens at 4 in the morning on a Sunday when you're groggy and don't know what's going on. But the point here is that once they were aware and knew what was going to happen and they were hovering over the keyboard, they got everything back up and running in less than an hour. It was about 40 minutes, and they lost 0 data because that replicating slave had been keeping up with the master, right? So their RPO turned out to be 0, and their RTO was about 40. It was 42 minutes or something like that, right? So that was a relatively cheap solution as well, right? They had one server. I believe it was an M2 extra large, and I forget what the pricing on that was, but they were paying for that on an instance hour basis. They had done a light utilization reserved instance for that, so they were saving additional money on that because they planned on having that DR server running all the time. And all the other servers were staged, right? None of them were running, none of them were incurring any cost. They were still taking snapshots of that slave database and pushing it out to S3, so there's a little bit of incremental cost there. But overall, that was a very, very cheap insurance policy, right? And that's really what you're doing with DR. It's about insurance, and it's just like auto insurance or car insurance. You're paying for something you hope you never need, so you find the minimum policy that meets your needs as far as cost is concerned, the minimum that you can spend to accomplish that. So like I said, we see a lot of our customers using this environment, using this disaster recovery. The most common one, like I said, is the on-premises production, and the cloud is DR, but we also have some folks that have flipped that as well. We have, like I said, to date, we haven't had any customers that have had to leverage it, but we have had a bunch of folks that have done, this one customer I'm talking about, like I said, did it in 40-something minutes. We have other customers that are more Windows-based, and you guys probably realize Windows take a little longer to boot, a little longer to install. So the RTO for this particular customer turned out to be like an hour and a half because of the additional Windows boot time and stuff like that. But still, for their business needs and their SLA, an hour and a half was an acceptable amount of downtime. And again, they had set up a mirror. They had a principal and a mirror in their on-premise. And then they had another mirror set up in the cloud. And as such, they had an RPO of 0 as well. Okay, so this is doable, right? And it's doable, and it's not only is it doable, it's doable in a fairly inexpensive manner. All right, so this is something, regardless if you use RightScale to do this or you use whatever tools, this is something I definitely recommend to you all that have a need for an SLA, a need for an RTO to your either business units or to your end customers or whoever it may be. Okay. So again, this is the second most common requested, but by far the first most common implemented that we see at RightScale. And then the third use case is data residency requirements. And this touches a little bit on, like I said, what Andy Jassy was saying as far as the companies that he sees that have this need to have certain workloads run in on-premises data centers. And he says that he feels that that will become a very small percentage of companies in the future. What I do want to talk about is we have two very recent customer use cases where this was a real problem. One of these customers is running a SaaS business. The vast majority of their customers are in the US. They also have some customers that are in Canada. And it was a Canadian bank, in fact. And the banking, and I'm not going to get this right, because the next one I'm going to talk about is an Italian one. I looked at the Italian law a little bit. The Canadian one, I kind of got hearsay. But what I understand is that the Canadian laws basically say for banking information, no financial information about Canadian banking customers can leave Canadian soil. It has to be stored in an encrypted manner in servers or in storage that's on Canadian soil. So this particular customer was running in AWS US East and in AWS US Oregon, but there are no Canadian AWS regions, at least not currently, right? So this was a pretty lucrative customer for them, a pretty big potential customer for them that they had to pass on because they were not able to meet these data residency needs, if you will. So what did they end up doing? They ended up standing up, in this case they used CloudStack, they ended up standing up CloudStack on-premises IT environment at a Canadian co-location facility. They use RightScale and this concept of the server templates that I mentioned. They use the same server templates in their AWS resources that they used in this Canadian colo facility underneath this cloud stack environment. And they were able to meet those data residency requirements of that Canadian customer. So they had their 90% running here in their SaaS business in the US under AWS, and they had a little 10% up there running in that Canadian data center, and it was all under that single pane of glass, the single management tool that RightScale provided to them. The second example was with a company that we're doing business with right now, and they have end user products. And these end user products, they had a promotion where you could, log onto their website, fill out a form, submit your, contact info. So I'm sure they email you and send you stuff in the mail or whatever. But the point being is that you could then win some of their products. And this was run in their Italian section. They're a global company, and this particular promotion was run in their Italian division or Italian business unit or whatever their terminology for it is. And Italy had a similar requirement with personally identifiable information: names, email addresses, physical addresses. Anytime you collected that information had to be stored, could not leave Italy, could not leave Italian soil. So AWS has an EU region in Ireland, but that didn't meet the need that they had. So for this particular customer, they're in the process of doing basically the same thing. They're actually going the OpenStack route, but they're in the process of finding an Italian colo facility that they can go ahead and stand up this OpenStack environment in to run this particular promotion. And they're envisioning that other countries may have similar requirements. And they're also going to do promotions in the future in Italy as well, right? So they're going to leverage this going forward also. But again, set up that private IT, private cloud environment there in that Italian data center, manage it under RightScale, allow that company to run that promotion and still meet those data residency requirements. So those two examples are not the company had these policies, right? But the government of the country they lived in had these policies. That's not something they could just, bypass, right? It's something they had to strictly adhere to. And without an environment, a hybrid IT environment such as this, they would have had to pass up on that opportunity. There really would have been no other way for them to do that other than getting in a standard, standard data center facility and running, having to manage that separately as opposed to managing it all under a single pane, okay? So those are probably the three most common use cases that we see. Like I said, disaster recovery by far the most common. Cloudbursting, we're starting to see more and more customers do that. And when we talk about connecting your clouds, I'll talk about why we're seeing more folks do that. And the data residency requirements are starting to pop up more and more. Like I said, we've had 2 use cases so far, but we envision quite a few more coming in the coming weeks, months, years, et cetera. Okay, so connecting your hybrid IT environment. Talk a little bit about the how, right? We've talked a lot about, talk a lot bit about the why people are doing it and what the needs are. We'll talk a little bit about the how, and this is, we'll get in a little bit of tech stuff, so I don't know what the audience is here. I apologize if this is something you guys aren't familiar with, and I apologize if others, it's old hat or whatever, but as I said, AWS Direct Connect, this is one of those placeholder slides, so ignore all the text that's on there, right? But basically the point here is that, how many of you here are familiar with AWS Direct Connect? What the concept is? Okay, great. AWS Direct Connect, sort of my version of it in the nutshell, is that if your gear is co-hosted is co-located in a facility that is supported by Direct Connect, and in the US it's typically CoreSite and Equinix data facilities, you can get an AWS Direct Connect link, which is basically one end of a fiber cable plugs into your router for your gear, and the other end plugs into an AWS router, right? So basically what that gives you is it gives you the ability for your on-premise gear running in this Equinix and or CoreSite facility to talk to your AWS cloud resources over a dedicated private link. No public internet traversal required, right? You can also pay for up to a 10 gigabit link. So it's anywhere from a 50 megabit up to a 10 gigabit link that you can pay for. Obviously the 10 gigabit links are a lot more expensive than the 50 megabit, but the point is you can get incredibly high bandwidth. You can get relatively reasonable cost, right? You pay for that per, what do they call it, port hour, I guess is what they call it. Every hour you have that port open, you pay a fixed cost. And then there's bandwidth egress, same rules as within regular AWS. Data coming in across Direct Connect is free. Data going out, you're going to pay at that sliding scale, right? The beauty of this as well is that it's also super low latency. Was anybody here by any chance in our boot camp, RightScale's boot camp yesterday? I don't recognize any faces. Oh, okay, we do have one. So the environment that we set up yesterday, right, was basically this, right? What we did is we set up in an Equinix facility. We're in Equinix SV1, which is in San Jose, and we had our gear running in OpenStack Folsom Cloud in that Equinix data facility. We had a direct connect to AWS US West. In our case, we hooked it up to US West 1B to make things simple. We were running a VPC, a virtual private cloud in US West 1B. We had that direct connect link between ours. We set up a subnet in the VPC. We set up a different subnet in our OpenStack cloud. We configured BGP, Border Gateway Protocol, for those who aren't familiar, to handle all the routing, the dynamic routing. And I could go ahead and I could ping a server from our on-premise, our OpenStack Folsom Cloud, and I could ping the VPC on the private IP addresses, and I had sub 3 millisecond latency, right? So I don't know if anybody here has done any of your own tests in AWS regions within the same availability zone. So for example, most of the tests I used to do were in US East because it was the first one, and a lot of these other regions weren't around when I was doing these testing. But if you ping within an AZ, you would see 500 microseconds was typically 300 to 500 microseconds, right? Screaming fast. Obviously, they're in the same building probably, or at least very, very close. If you pinged AZ to AZ, so I pinged US East 1A to 1B, I typically see about 2 milliseconds, right? So the fact that we now have this 2.8 was our average, right? 2.8 millisecond latency between our own stuff and our AWS cloud resources, it's like another AZ, right? So the latency issue is gone, right? The latency issue is not a problem anymore. The security issue is not a problem anymore. We're running a VPC. We set up our own subnets. We set up our own routing. We've taken care of all of that. So security, latency aren't a problem, and as long as you can absorb the cost, then it's a wonderful solution. So that is available in almost all regions of AWS, right? Like I said, here in the US, it's like Equinix and CoreSite. In other countries, it's like Terramark, and Earcom, Telecity, I think in Sydney, those kinds of things. So there are environments out there where you can set up Direct Connect as well in other regions of the world. Was there a question, sorry? Mm-hmm.
Internal IT, so I have a data center in Denver, a data center in Dallas, and I run Direct Connects with AWS.
Thank you. That's a very good point. So there's AWS partner network, APN partners, technology partners that you can leverage their existing connects from those data centers to the facilities in which the AWS infrastructure is running as well. So thank you very much for the clarification. It's a very good point. So the point is that there are a lot of options out there, right? And if you are in an environment where Direct Connect makes sense and is possible, and this is something you're interested in, this Cloudbursting concept, definitely recommend it, right? It really is very, very appealing, all right? And as I said, the customers that we've seen that have implemented Cloudbursting, this is the way that they've gone. They've gone with this solution. They've ended out in a Direct Connect facility to set this up for themselves. The lab that we did yesterday was set up exactly like this as well. We did not want to, we could have dealt with public internet traversal, but we did want to do what we recommend as a best practice. Yes, sir.
Is there any partnership with any of the telecoms like AT&T, Verizon, Connect like AWS network?
There is, I don't know, the question was, are there any things like the telecoms that are partnering with AWS in this regard? If you go to AWS's Direct Connect page, it's like aws.amazon.com/Direct Connect. They have a list of all the APN partners that are supporting this. So I haven't looked at it in a while. There may be. The only ones that I'm intimately familiar with are Equinix and CoreSite. Those are the ones that I typically deal with. But there is a larger list there as well. Yeah. So that's where I would definitely take a look. And that can point you to where your gear, where are the supported facilities, and then also give information on pricing and how to configure it and all that kind of stuff. So we'll go my cheat sheet here and see if there's anything else I wanted to mention to you guys. Nope, that was pretty much it. So the second one that I want to talk about is on-premises hardware device. And this is for customers, and we have some of our enterprise customers that have some big honking Cisco box, or they have a Juniper Networks box, or they've got a Yamaha router, or whatever it may be, that speaks BGP, and they want to go ahead and they want to leverage that to create this encrypted tunnel between the two. What they do in this case is that you're running in AWS in an AWS region. For example, we have one customer, these guys are in Oregon as well. They're running in Oregon, they're running a VPC. You don't have to do it in a VPC, they're doing it in a VPC. What they've then done is they've used the the AWS console to go ahead and create a VPN connection, right? If you're familiar with the VPC, you can go ahead and using their wizard, create an VPN connection on that side. And what they've done then is they've set up their Juniper Network box in their facility to speak the other end, if you will, of that VPN connection. So they have that VPN connectivity between the cloud, the VPC and the cloud. They're using a virtual private gateway, which you also have to set up, and I won't go into the details of that. It's spelled out pretty well on the AWS VPC site. Basically, the VPC with a VPG, Virtual Private Gateway. They have that VPN connection that's running down to their dedicated gear. In this case, it was a Juniper Networks box. That's the other end of that VPN connection. And then behind that, they have all of their on-premises resources, right? And these folks were running an OpenStack cloud as well. So basically, they have this encrypted VPN tunnel, right? So the security is taken care of. Security, they're all good on. Now, the nice thing about this is it doesn't matter what region you're in. It doesn't matter where your on-premises gear is. You can do this anywhere because you're traversing the public internet, right? There's no direct connect involved, so you can do A and B can be anywhere you want. Now, that's a good thing and a bad thing, right? Because now security is taken care of, but you still have to worry about latency, and you still have to worry about cost, right? You're still paying on that egress cost out of AWS, and depending on your ISP provider or wherever your gear is, you might be paying ingress and or egress for that data, right? So again, the same three things come into play. Security is probably handled for you at a pretty reasonable level. You have to worry about latency, and you have to worry about cost. For this particular customer, they were leveraging this environment. They were bursting to handle batch processing stuff. So there was no user involved, and a little bit of latency didn't really matter. If something took 3 seconds as opposed to 2.5, it did not matter, right? So for that use case, they had no need to do a direct connect and pay that extra, A, go through the extra complexity, and B, pay the extra cost for that direct connect, because latency wasn't a big deal to these guys. From a cost perspective, they had everything in S3, so there really wasn't any bandwidth cost. They were just basically pulling stuff down locally, doing whatever they needed to do, and just sending results back and forth. So the bandwidth was relatively low as well. So for their particular use case, Cloudbursting was great, and using the public internet as their traversal mechanism was acceptable as well. All right? And then the third one, the last one I want to talk about, pure software base. Right? And obviously, you're running VMs in AWS. It's your VM. You can run anything on there you want. Right? So we have other customers that are running, for those who are familiar with some of these technologies, OpenSSL, OpenSwan, pfSense, Raccoon, a whole bunch of stuff, right? There's a whole slew of options out there you can do this. So what some folks have done is set up an OpenSSL server in AWS, not in a VPC. They just have their regular old AWS resources. They've set up an OpenSSL server. They have an OpenSSL client in their on-premises stuff, and that's how they do the encryption between the two, right? Other folks are using OpenSwan, familiar with SSL versus IPsec. OpenSwan is an IPsec one, so it does it at a little lower of the Internet Protocol suite. It's at the internet layer as opposed to the application layer. Some folks are more comfortable doing their encryption down lower, or they have regulations that say you have to do the encryption at the non-application layer. So in that case, IPsec makes a lot of sense. If not, OpenSSL is, in my opinion, a little bit easier to set up, but that doesn't mean it's going to meet the compliance requirements of your particular environment. But the point here being is that software to software. There's no hardware involved. You can have a VPC up here. You don't have to have a VPC up here. You've basically created your own encrypted VPN tunnel between point A and B. And now the normal 3 caveats come in. Encryption, security, you've probably taken care of that. Hopefully you're using a decent encryption mechanism, right? But cost and latency, again, factor into that equation as well. So if your use case can tolerate the cost and latency, or if the cost is not too high and you can tolerate the latency, a software-only solution such as that might be a good way to go. There's no additional costs, right, other than the typical bandwidth costs and that kind of stuff. You don't have to have on-premise gear that you have to manage or own or anything like that, right? So this is sort of an umbrella, but these are probably the 3 most common umbrella use cases that we see. AWS Direct Connect for sure. Folks that have their own gear and they're connecting up typically to a VPN connection to their VPC in AWS. And other folks that are just going software to software and however the heck they want to set it up, right? Like I said, there's a lot of different variations on the tools that you can use there. Most common ones being probably OpenSSL and OpenSwan. Now, what you can also do as well, and some of our customers have done, and we actually used it in our lab as a backup plan, right? We went through AWS Direct Connect, and it was, it's a little bit, not arduous is the wrong word, it just takes a little time. There's a lot of paperwork to sign and all this, logistics to sort out. Time was getting kind of near the end, and we didn't quite have it set up yet, so we wanted to set up a backup plan. So what we did is we had a VPC in US West. We created a VPN connection using the AWS console. And in our OpenStack Folsom Cloud, we actually ran a VM that we ran pfSense on. And we told all the other VMs that we gave that a fixed IP, and we told all the other VMs route all your traffic through that fixed IP. So that became the other end of our VPN tunnel, essentially. Now you can run that on a VM. Now granted, now you're going through the cloud controller to get to that VM. Or you can actually run, in this case, you could have run pfSense on the actual node that was running, for example, our Nova Compute. We could have actually run that as a process on that and sort of that would have been outside, if you will, of that OpenStack Folsom Cloud. But you can run it either on a VM within the on-premises environment or on the physical node that is hosting that on-premises physical environment. Okay? Okay, a little bit about management. Now we've kind of talked about how people are using it, why they're using it, what the pros are, what the cons are, and then some of the use cases. Talk about management. One thing that we've seen really become much, much more popular with particular enterprise customers is the concept of self-service IT. What we used to call the IT vending machine, and I think we're kind of leveraging more of the self-service IT model. Basically, this is the ability for IT to present to their end users a GUI portal, right? Access to their resource, access to cloud resources without them having to actually access the cloud or worry about API calls or any of that kind of stuff, right? So we have, and I'll give a little promo here, but we have a demo that we can show you guys at the RightScale booth out there in the reInvent Central or whatever they call it. We can kind of walk you through what we have as far as the IT vending machine or the self-service IT. But the common theme is here is that what it does is it gives the ability to give a single portal with a couple big red buttons on it, and you present that to your end users, and there's a button that says, launch me a 3-tier PHP stack, or launch me an all-in-one LAMP box, or launch me a Windows server, or whatever it may be. They click that big red button. What happens behind the scenes? I think I have a slide. Yeah, okay, good. So I want to talk through this. So you've got your developers, your end users, right, that are sitting in front of this self-service portal that either you have skinned yourself, or we have we actually have an open source project that's in GitHub, which kind of gives you our generic skin, if you will, on top of that. Basically, the end users interact with that self-service portal. They click one of those big red buttons. It makes a call to the RightScale API, which is accessing our multi-cloud platform, and depending on which big red button they clicked, they're making a call out to either their on-premises resources or to their AWS resources to go ahead and spin up those VMs. And using the server template methodology that I mentioned to you guys before, the ability to have this same exact server run regardless of which environment it is, they can go ahead and spin up a dev test stack on their on-premises or an identical dev test stack in AWS or a 3-tier, wherever it may be, whatever the case may be. And then it gives the end user access, either through the GUI or it gives them SSH keys or whatever it is that they need to get access to those resources. They never need to make an API call to AWS or to your cloud controller. They never need to see the RightScale dash, right? And they are completely siloed and segmented, right? See, a lot of folks use this for test and dev. It's probably the most common use case, at least initially. A developer has the ability to stand up his own LAMP box by clicking a big button. He has access to it. If he accidentally dropped tables in MySQL, he's only screwed himself. He hasn't messed with anybody else, right? He can always say kill, relaunch, and he gets another one brand new, right? So that's where we see a lot of initial uptake, but there's a lot more that we can add to this, and we will be adding it as a product, a feature of our cloud management product going forward. So I think I kind of touched on most of the bullet points there on the side. The other thing is, from a management perspective, I want to talk a little bit about governance. There's this from James Staten, Forrester Research wrote this a while back. He said, for every cloud project you know about, there may be 3 to 5 others that you don't know about, right? And this is sort of the shadow IT concept that folks are talking about a lot. Basically, folks going around the IT department to get what they need because the IT department takes so long, right? And the comment they make there is it's not a rebellion, right? But folks are trying to be productive, right? If you put obstacles in front of smart, creative people, they're going to find ways around those obstacles, right? So remove the obstacles. Make it easy for them to do what they want to do and still give you the visibility into what they're doing, and they'll use it, right? As long as I can do what I need to do quickly and rapidly and I don't have to jump through a bunch of hoops, sure, I'll use it. I don't want to spend my time hacking around this thing if you've given me what I need. And if you've given me what I need and it gives you the ability to do security and compliance checking and billing and chargeback information and visibility and all that, all the better. Right, all the better. I don't care if you have that visibility. All I want is get access to my resources in a quick and efficient manner, right? So that's where this governance kind of concept comes in, and the ability to see all this under a single pane of glass and or get your own self-service portal up and running so that users can access the resources through that. Standardization through automation. Cloud builds are everywhere, right? You've got anybody that's trying to manage their own images. Right? One of the things, again, a little RightScale plug here or whatever, but we have this concept of what we call a multi-cloud image or an MCI. And an MCI is sort of an umbrella over all of these write images, which are sort of our version of an AMI, if you're familiar with that. We have an MCI, which is an umbrella over all these right images, and we have a right image for US Oregon, and one for US West, and one for US East, and one for Sydney, and one for OpenStack on KVM, and one for CloudStack using Zen, and one for CloudStack using ESXi, or whatever it may be. So you have this one MCI, you have a server template, you say, okay, I want to use CentOS 6.5. Okay, you choose the CentOS 6.5 MCI. I want to launch it in this particular resource pool. I'm going to launch it in US West. Boom, we automatically choose that image for you. And those images are they're not binary identical, but as far as functionally identical, right? If you launch that at right image in US East and you launch it in US West, you logged in, you did a PS or you did an LS, you'd see the exact same stuff, right? We go ahead and create basically the identical images. So we've taken care of all that for you, right? And we're managing over 50, 60, I don't know, it's probably more than that, images at this point. My point being is that if you guys want to make yourself multi-cloud aware, you've got to take on that responsibility now, right? You've got to have all those images, and you've got to either copy them around, move them around, recreate them when you update a package, that kind of stuff, right? So supporting all that can be a nightmare. So there's a comment here, from Gartner again that says, by 2016, more than 70% of the large enterprises will choose a heterogeneous IT operations management vendor instead of the infrastructure vendor because of this sprawl, if you will, right? It becomes sort of an intractable, unmanageable problem if you want to go outside of the world of using one particular resource provider. Right? The last thing I want to touch on is cost management. And this is something that we've seen a lot of our customers, obviously cost is important, a lot of our customers have been asking us about to sort of have improved features around. And we've been fortunate in that when you're a RightScale user, when you're a RightScale customer, anytime we have your credentials, we're collecting all your usage data, and we have since day one when you signed up. So if you're a customer of ours for 5 years, we've got 5 years of the historical usage data for you, right? There's a lot of good information to be gleaned from that data, right? So we've had folks that have been asking, hey, can you help me leverage this information, right? So Andy Jassy today mentioned, I'm sorry, they call it expert advise? No, trusted advisor? Sorry, trusted advisor. The trusted advisor concept, right? And that's basically an automated process that goes through and looks at your instances and that kind of stuff and says, hey, this one's only been 5% utilized or it's been 0% utilized, right? It's an automated process that goes through there. What we have is this thing called Cloud Analytics, which is sort of a deeper dive on that. And we just announced it last week. We're now signing up beta users, so it's available for beta users to log into. But it gives you the ability here to visualize all of your IT costs. So anytime, regardless of which cloud, obviously AWS or any other cloud vendor that you have credentials in RightScale submitted for, we have all the historical data. You can go ahead and look at that data over any particular period of time or for all time and see where your usage was, where you were spending, where you maybe were underspending, where you may be overspending. You also can slice and dice the data on different parameters. Who did what? Who launched these servers? What regions were they running in? How many M1 larges did I have versus M1 smalls, et cetera, et cetera, et cetera. You can also forecast your future spend by adding patterns. So some of our customers are saying, hey, we're seeing 5% month-over-month growth. Great, okay, you can go ahead and punch that in. You can see the next 3 years, what that looks like. Or you can say, hey, I'm a e-commerce site, and between Black Friday and January 1, I get hammered. I get 200% increase. Okay, you can implement that pattern and see how that works out over time. So it allows you to forecast your spend, find where maybe you're underspending or overspending, and help you to optimize those usage costs. And allows you, like I said, to build those patterns to play what-if type scenarios as well. We have a product manager from Cloud Analytics who's here and giving demos in our little demo theater. So if you guys are interested in that, please stop by. It is pretty cool. It's something we just released, and we are looking for beta customers here very, very shortly to sign up for it. I think that's everything I had. That is everything I had. So I have about 6 minutes left. If anybody has any questions, I'll be glad to entertain them. Anyone? Anyone? Going once? All right. Thank you very much for your time. I really appreciate it.